Have you ever stopped to think about how your phone knows your face, or how your favorite streaming service just gets you, recommending the perfect movie every time? Well, it's not magic, I can tell you that. Today, we're going to pull back the curtain on the three main ways that machines actually learn. So let's dive right in. Yeah, all that amazing stuff is powered by a process, not just a bunch of pre-written rules someone typed out. So what's really happening under the hood? Well, it all boils down to one core concept. At its heart, machine learning is exactly what it sounds like. Instead of us having to code every single step, we just feed a computer a whole bunch of data and basically say, hey, you figure out the patterns. It learns from experience, kind of like we do. But here's the thing. This learning process isn't a one-size-fits-all deal. Nope. It's actually broken down into three main methods, and each one has a totally unique way of looking at the world. Let's meet the first one.
Okay, first up, we've got the most common type, and it's called supervised learning. And honestly, the name gives you a massive clue about how it works. There's always a supervisor, or maybe a teacher, guiding the whole process.
The absolute best way to get this is to think about studying with flashcards. You know how it goes. You've got a question on one side, and the correct answer is right there on the other. You make a guess, you flip it over, and you see if you got it right. A computer doing supervised learning is doing that exact same thing, just, millions of times faster. And that brings us to the key ingredient here, something called labeled data. This just means all the information we give the machine is already neatly organized with the correct answers. So imagine feeding it thousands of pictures where each one is explicitly tagged cat, not a cat. The machine makes a guess, checks it against that correct label, and just keeps tweaking its own logic until it gets it right pretty much every time. And believe me, you see this every single day. That spam filter in your inbox, that's supervised learning. It was trained on tons of emails that humans already labeled as either spam or not spam. It's the same idea behind systems that predict house prices, or even ones that help doctors diagnose diseases from patient charts. Now, behind the scenes, you've got these powerful algorithms doing all the heavy lifting. We're not going to get into the crazy math, but you might hear names thrown around like linear regression or decision trees. Just think of them as the engines of supervised learning. The main thing to remember is this. If you have a clear question and a bunch of data that already has the answers, supervised learning is probably your best bet.
Okay, but what if you don't have an answer key, right? What happens when you're just handed this huge, messy pile of data and someone just says, make sense of this? Well, that's where our second type, unsupervised learning, steps in.
The perfect way to picture this is to imagine someone dumping a giant, mixed-up bucket of Legos on your floor. There's no instruction manual, no picture on a box. What do? Your first instinct is probably to start sorting them, right? You'd put all the red ones here, the blue ones there, maybe group them by size or shape. You're not building anything specific yet, you're just finding the structure in all that chaos. And that is precisely what a machine does with what we call unlabeled data. It just digs through everything, looking for natural groups and connections that a person might never even spot. The whole goal isn't prediction, it's just pure discovery.
So putting them side by side really makes it clear, doesn't it? Supervised learning is like that student with the answer key, totally focused on predicting the right answer. Unsupervised learning, on the other hand, is more like a detective, just sifting through all the clues to find patterns you didn't even know you should be looking for.
So where is this actually useful? Well, think about a recommendation engine. It can use unsupervised learning to group together customers who have similar tastes, creating these little segments for better suggestions. Or banks use this same idea to spot weird transaction patterns that could be fraud. It's all about finding those important signals that are hiding in all the noise. All right, so we've met the teacher, which was supervised learning, and the detective, unsupervised learning. Our third and final type is a whole different animal. Let's meet the explorer, an agent that learns from nothing but pure trial and error. This is reinforcement learning. Honestly, if you've ever taught a dog a new trick, you've used a basic version of this. When the dog finally sits, it gets a treat. That's a positive reward. When it does something wrong, it gets a firm no. That's a penalty. After a while, the dog just figures out which actions get it the most treats. It works the exact same way for a machine, or what we call an agent. It tries an action out in the world, it gets feedback, good points or bad points, and its only goal, its entire purpose, is to figure out the series of moves that will rack up the highest possible score. It learns through literally millions of cycles of trial and error. And this is the technique behind some of the most mind-blowing stuff in AI. Those systems that can beat the world's best chess players, or AIs that master super complex video games. They learned through reinforcement learning. It's the same core concept that helps a self-driving car learn to navigate traffic or teaches a robot how to walk. And there you have it, the 3 core ways machines learn. Learning with an answer key, learning by finding hidden clumps of data, and learning by just trying stuff out. So let's put them all side by side one last time to see how they really stack up.
This table really sums it up nicely. Supervised learning is your go-to for prediction, when you already know what you're looking for. Unsupervised learning is all about discovery, for when you need to find those hidden gems in your data. And reinforcement learning, that excels at complex decision-making, teaching something how to operate in the real world. Each one is basically a different superpower for a different kind of problem.
And here's what I really want you to take away from all this. Once you get a solid handle on these 3 fundamental ideas, the entire, sometimes confusing world of AI really starts to make sense. This is the bedrock. Everything else is built right on top of this. Which, of course, leaves us with one heck of a question. Is it going to be the steady, reliable predictions from supervised learning, the deep, surprising insights from unsupervised learning, or the incredible, autonomous decisions of reinforcement learning? Which one do you think will have the biggest impact on our future? The race is definitely on.